morning. We will continue our numerical problems on RMS and average values of AC signals. In the last lecture, we have seen the numerical problems on sawtooth waveform and pulse waveform, and also on triangular waveforms. In this lecture, we will try to determine average and RMS values of a pure sinusoidal wave and also a trapezoidal wave if possible. So I'll start with the numerical problem on a trapezoid. Now if you carefully see, here is a signal which is taking a weird shape, right? It is not just like our conventional signal. So if you carefully see the signal, you see that it has so many parts, and you are supposed to determine the RMS and average value of this particular signal. So our basic steps we will follow. The first step is to determine the time period of the signal. If we look at the signal, now see, from 0 to, I'll take this one as 1, okay, from 0 to 1, which is a duration of 1 second, it is 0, and from 1 to 2, it is taking a straight line, and again from 2 to 4, it is constant at 3, and again from 4 to 6, it is 0, right, and again from, say, I'll take this one as the middle point. Okay, so this is, I'll take it as 7. So again there is a straight line. Again for 2 seconds it is 3 value, its magnitude is 3. And again for 2 seconds it is dying out. So if you carefully see, if I start at 0, the time period is not up to 4 seconds. The time period will be up to 5 seconds if you carefully see, because here before the start of this line signal I do have a time period of only, I do have a time of only 1 second where it is 0. So here also it must be a time period duration of only 1 second to be at 0. So which means that this part, it comes under the first pattern itself, or the first part of the waveform. So now this is your actual waveform. So for the first 1 second it is 0, and from 1 to 2 seconds it is a straight line, and from 2 to 4 it is remaining constant at 3, and again from 4 to 5 it is 0. So the same thing is repeating here again and again if you carefully see. So 1 second 0, 1 second straight line, next 2 seconds it is constant, again 1 second. So again it is repeating after 5 seconds. So don't get confused in the examinations. Don't get confused that at the end of this signal the time period is going to end. So you must be carefully looking at these points also. Okay. So in this one, if you carefully see, the time period is now up to 5 seconds. And in 5 seconds, how many parts are there? From 0 to 1, it is 0. From 1 to 2, it is a straight line. From 2 to 4, it is a constant value. So let us write the equations of this one. From 0 to 1, see. From 0 to 1, it is a value is 0. From 1 to 2 seconds, it is a straight line, right? So the 2 points of the straight line, one is 1, 0, the other one is 2, 3. So what is the straight line which is joining the 2 points now? Y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. Right. So I'll take this one as x1 y1 and I'll take this 2 as x2 y2. So if I substitute these things, I'll get y minus 0 by 3 minus 0 is equal to x minus 1 by 2 minus 1. So it is 1, it is 3. So I'll get y is equal to 3x minus 3. So in my case, on x-axis it is t, whereas on y-axis it is voltage. So I'll take it as 3t minus 3. So from 0 to 1 second, its value is 3t minus 3. And from again 2 to 4, its value is 3. And again from 4 to 5, its value is 0. So like that, I have divided my waveform. See, from 0 to 1, its value is 0. From 1 to 2, it is a straight line which is having a slope. And the equation is 3t minus 3. From 2 to 4, it is constant at value of 3. And from 4 to 5, its value is 0. So this is step number 1, finding out the time duration. This is step number 2, writing the equation. Once I have done it, I'll move on to average value and RMS value of the waveform. So first of all, the average value of the waveform. When I look into this average value of the waveform, see, the standard equation is this one. 1 by t integral of 0 to t v of t dt, isn't it? So my time period is 5 seconds. So I can take from 0 to 5, or I can take from 5 to 10, or I can take from 10 to 15. But for ease of doing, so I'll take from 0 to 5. So from time period is 5, whereas conduction time I am considering from 0 to 5. And later on, I am dividing this one into 4 intervals. First is 0 to 1, and then 1 to 2, and then 2 to 4, and then 4 to 5. See, 0 to 1, 1 to 2, 2 to 4, 4 to 5. 0 to 1, its value is 0. 2 to 1, its value is 3t minus 3. 2 to 4, its value is constant at 3. And again, it is becoming 0. So, I'll replace these expressions. Now, this is my equation. Now, for this one, I'll get 0 defaultly because it is 0. For this one, for 3t, it is 3t square by 2. So, I can write it as 1.5t square minus 3t, varying from 1 to 2. T value is from 1 to 2. Here for 3, I'll be getting 3t. So 2 to 4. Whereas here again it is 0. Right. So first of all, let me substitute 2 here. If I substitute 2, I'll get 1.5 into 2 square. That is 1.5 into 2 square. 2 square is 4. 4 into 1.5 is 6 minus 3 2s is 6. I'll get 0. Right. Here, when I substitute 1, what I'll get? It is 1.5 minus 3 I'll get. So, on the whole, I'll be getting a 1.5. So, that is what which I meant to write it here. It is 1.5. And here it is 3t. 3 4s are 12 minus 3 2s are 6. So I'll be getting a value of 6 here. This is what I have written here. The rest of all are 2. So if I solve this one, I'll be getting 7.5 by 5, and the value is 1.5 volts. Now if I want to do it for RMS value, then what I should do, I should apply a square root here, and internally I am supposed to square these things. So this is what I have done here. I have applied a square root here, and these internal terms I have squared here. So when I have squared, 0 square remains 0, whereas 3t minus 3 whole square, it is a minus b whole square. So I'll write it as a square minus 2ab plus b square. And 3 square, I'll take it as 9, 0 square again becomes 0. So now when we start to integrate it, 0 remains 0, so I'll leave it to 0, whereas 9t square becomes 9t cube by 3. Which is 3t cube minus 9t square plus 9t, where t varies from 1 to 2. And here again it is 9t, where t varies from 2 to 4. So when I substitute these values, I'll be getting a final value of 2.049 volts. Okay, try to calculate this thing with your calculator. So this is the way how we determine the average and RMS values. Okay, this is I have done for trapezoidal, and in the next video lecture we will see for a pure sinusoidal. Okay.